Hi, and welcome back to Accounting 482. This is session 34, and we're continuing along with our Making Business Decisions module. And the last sessions, we talked about making tactical decisions, and we talked about relevant information. We did some examples. Now we're moving over to capital investment decisions, and these are bigger decisions, and they take a lot more time and a lot more resources to implement. So, oh, I gotta click that every time. I tried to do the the slideshow with this one, and because it's got some really cool stuff later, but I have to switch back and forth between my documents, so it's not going to work that way. So, what we're doing this session is we're looking at the time value of money and then methods of comparison. And this gets into the big decisions for business, whether they want to start a new line or build a new plant or, purchase new equipment. And this can also go in hand with your personal decisions because we all eventually buy a house or we look at buying a car or we save for retirement. So this is time value of money, and I really do like this part, this session, and I know that you've probably been introduced to this in accounting too. Well, probably in 201 and a little bit in 202, but this is a refresher, and it gives you a little more information about how we use this information. So the principle of is interest is the amount a borrower has to pay, right, for the right to borrow the money, and that's added to the principal of the loan. So if you were going to give somebody $20 and they said, okay, I need to borrow $20, and at the end of the week I'll give you 21, you think, great, that's $1 interest for that $20. And that's great. But the amount of interest charged is given by the annual interest rate and is made of three parts. So if you go to the bank, they want interest and it's more formal. You wouldn't go to the bank to borrow $20. Hopefully you would have some resources available to you, whether it be a roommate or a friend or your parents, to give you that $20. But if you need to borrow money from the bank, they're going to charge you interest. And there's three parts of the interest that go into making up the rate. The first is the inflation rate. And this is this section or part of this equation is what the Fed rate is. And it's tied to the Fed rate, and it can go up or down depending on the Fed rate. Now the pure rate is the rate of what the bank wants you to get, pure rate. And then the credit risk rate is how risky you are. So if you want credit and you have good credit, your credit risk rate is going to be lower than somebody with bad credit. And I'm sure that you have read, or if you have seen online or in any financial class, that people who have better credit pay less interest on their money, and therefore they save a lot of money over time. So the best thing that you can do for your personal finances is to keep your credit rate high. And this is tough to do, but if you are responsible with your money, it will save you a ton of money down the road. For instance, my very first car, now this is back in the 80s, I know, I bought a car and I had it on payments, and I believe my interest rate was about 15%. Huge. That's a huge amount of interest. But it was because it was my very first automobile and I didn't have a lot of credit. Now, we just paid off we have a truck and we just paid it off, but the interest rate on that loan was 2.99% for a lot of different reasons. The Fed rate was a lot lower, so the pure rate is a lot lower, and our credit risk rate was really low because we have good credit. But I know that some auto loans right now, they're advertising 9.99%. And this is for the people who don't have a lot of credit or have bad credit. And so that all takes time to get your credit rating up so that you can pay less over time. And it is very helpful if you keep that in mind when you apply for credit and when you understand your credit, the interest that's charged to you. Okay, now we're going to go on to the class. So, simple interest and compound interest, they're pretty easy concepts. Now, simple interest is just principal times interest times time, a number of periods. And we're going to use number of periods in this module because interest can be paid or it can be paid or received once a month. It can be received twice a year or yearly. So we're going to use periods. And now compound interest is paid on both the principal and the unpaid interest. Okay. And so it's calculated as the beginning balance multiplied by the interest rate for each period. And for each period, and they do it separately so that the beginning balance can be included in the last period's interest. So, and that is kind of convoluted, but I will show you, it's easier to show you than to tell you. So, know that most, like if you get a credit card, they compound that interest every day. Every day. Simple interest, I think that even banks do compound interest, and I'm not sure in a savings account how much they, how often they compound that interest. It probably depends on the bank. But if you owe a credit card company money, that interest is compounded every single day. So, example 1, simple versus compound interest. Now, assume that you want to invest $5,000 for a new car, and that's pretty low. You want a new car, and maybe that's the down payment on a new car, and your bank offers a 4% CD for 5 years. Now, what is a CD? A certificate of deposit is what that is, and it pays a little bit higher than a normal savings account. What you do is you put $5,000 in the bank, you buy a CD, and you cannot take that out for 5 years. And that's why they pay you higher, because they have that money in the bank and they know that you're going to keep it in the bank. And they know that in 5 years they need to give you that money back. So, and what they do, what banks do, if you might know this, banks take money from savers, and then they use that money to loan out to borrowers. And that's just how banks work. So, if they get your money for 5 years, they're going to pay you a larger interest rate. So now how much will you have if the CD pays simple interest, and how much will you have if the CD pays compound interest annually and semi-annual? So, we are going to go to our handy dandy notes, and we're going to do simple interest. So we've got the principal. I'm not where I'm supposed to be on my keyboard. That'll make it a mess, won't it? Your principal. I am having spelling issues today. Okay, the principal for simple interest. Let's do simple interest. Simple interest. Its principal multiplied by the percent, okay, the percent of your interest multiplied by your number of years, or your N. We're going to say that's your N. And I know, okay, it's fine. So, it just doesn't like how I do some things. Okay. Okay, so your principal is $5,000. And our interest rate is 4%, right? 4%. And our N is 5 years. And if you multiply all of that out, you're going to get $1,000 in interest, plus you're going to get your $5,000 back. Not $50,000. And that's going to give you $6,000. So, in 5 years at 4%, your $5,000 is going to turn into $6,000. Not too bad. I'm going to move this up. I knew this was going to happen. I've got some charts and they bumped down. Now, so compound interest is equal to compound interest, right? So it's the principal times the percent times the number of N, or years. Now, N will change with compound interest because we're going to compound the interest at different intervals. Now, going back to the PowerPoint slide, we're going to look at it annually, and then we're going to look at it semi-annually. And this takes a little more work, and of course, and everything today, I'll move that up. Everything today, there are programs that allow you to easily do this in a calculator or online. But in the interest to show you exactly how this occurs, I'll do this out the long way. I did make the charts because it's a little easier. So the beginning total is $5,000. And my interest rate is 5%. Let's put this up here. 4%, sorry. Interest rate is 4%. And we're going to take this $5,000, multiply it by 0.4%, and our interest is going to give us $200. Okay, so $4%. $2,000, and our total now is going to be $5,200. So our second period is going to be, this is period 1, this is 1, okay. How am I going to do that? 1. And then 2 is going to be my $5,000. I'm sorry, $5,200 multiplied by the 4%. And that is going to give us $208 of interest. And now we're going to have $5,408,000. No, I'm sorry, $5,408. And in 3, we're going to keep doing that. So our next interest, the interest on $5,408 is $216. We're going to add that together, and we have $5,624, period 4. Our interest of $5,624 multiplied by the 4% is going to give us $225. And we're going to add that to our total, and that's going to give us $5,849. And I need to turn that off. Where is it even? Found it. Okay, and 5. I usually remember that, but I didn't this time. Sorry about that. And our interest on $5,849 is $234. And now our total at the end of 5 years is $6,083. Now you think $83 more is really not that much. But if you're going to get $83 more, that is a lot. And it's only $5,000. So if you can imagine having a lot of money in your savings, then in your CD, then it would be a lot. So now let's try this. Here is annually. Annually. Still not correct. Annually. And this is semi-annually. Okay. I've got a little more room. I can add a line. So now here we've got the beginning, and it is $5,000 again. And we have 10 periods. So if it's still a 5-year CD and they're paying semi-annual interest, we're going to have 10 periods, right? 10 periods. So I'm just going to go ahead and do 10 periods. And again, our interest is 4%. So I'll put that in here, 4%. And we're going to do the same process, except we are going to have more periods. We're going to pay, we're going to get more interest, and it's going to add up faster. So it's 5,100. And now that you have the gist, I'm going to try to do this faster so so we can move on. And I do think that this is a great way. I mean, it is a great way to look at this because some people don't really know how this is done. And this shows you the end result. People can figure out the end result, but they can't see the process. And so this is a little better. Okay. And $110. So every 6 months you're getting more money. 113 jumps up because our balance is higher now. And 115. And of course I'm rounding, so that would be different. And 117. 5,975. And 120. $6,095. So now compounded semi-annually will give you even more money. So here's our totals. We have $6,000 for simple interest, $6,083 for compounded annually, and then $6,095 compounded semi-annually. So that's pretty cool. That gives us a little more than we had before. Now, the power of time, the amount of interest earned or owed can be greatly increased by changing the compounding period. And it didn't show very much difference in our example, but if you had, say, a home right? Or if you owed money on a credit card, that extra money would be a burden to you. So now, as a borrower, you want the interest to compound as little as possible. And of course, if you are the lender, you want the interest to be compounded as much as possible. So credit card companies do a daily compound, but a bank will not do it that fast, I don't think. It depends on the bank. But so you can see how there's a conflict there, depending on what you have, the interest, what if you owe the interest or if you're being paid the interest. And the reason that they pay, one of the reasons that they charge interest is because you don't have the money, they have the money, you need the money, and want, they want you to pay for that fact that you don't have the money and they have the money. So that's what interest is all about. And part of that risk rate is that. So now, because of this principle, we seldom talk about years when dealing with investments. Again, we talk about the periods because depending on how many times that interest is compounded, that gives us our periods. And I know that you've used the tables in in your accounting classes, and we're going to use the same tables in this class because we have them available, and I want everybody to have the same information so that our calculations are the same. Because if everybody used a different type of financial calculator or something off the internet, our results will be different, and using the tables should result in the same answers for everybody. Now, the power of time is kind of interesting because you think, well, does it really compound that fast? Well, if I said to you, I will give you $1 million today, or 1 penny that doubles in value every day, what would you think is the best investment? The best investment for you? The best gift that I will give you? Now, if you think about it, most people would think that the $1 million is the better deal, right? Well, I'm going to show you my scan right here. And I tried it twice, and I don't know why it's crooked, but I tried to get that straight. So here's the power of time. $1 million or a penny doubled every day for 30 days. Did I say a year? 30 days. And if you look here, okay, $1 million, getting up there, 22 day, 23, 25, 26, day 26. So day 27, we get over $1 million. Okay. By day 28, we're looking at 2.6, almost $2.7 million. We still have 2 days left, right? 2 days to double that. By the 29th day, we have over $5 million. Okay. Day 30, $10.7 million. That's just the power of time. And people who retire, okay, this is off the class, but people who retire with a good retirement start saving early, like in your 20s. They save as much as they can, as long as they can, and by the time you retire in your 60s, you'll be set. I'm just saying. I never thought that I would be able to retire, but I started saving early in my 20s, and it's looking pretty possible right now. So I'm just saying, save early, save often, and you'll be in good shape. Okay, I'm done. Anyway, so we talk about the periods when we're doing the power of time. And now, the time value of money, the concept is that $100 will be worth more today than it will be in 10 years. If you think about, um, back in the day, back in my day, things were really cheap, considering. But even just 10 years ago, would we think that we would pay 800 or 900 or $1,000 for a phone? No, 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 no. We would, we just, that just seemed like a lot. But now we do. But cell phones are kind of strange because back in the 80s when they had the mobile phones, a real big, like a brick, it looked like a brick, those were like $2,500 to buy this mobile phone for your car. I never had one, no. No, I didn't have a car till I was like 18. So, um, yeah, they were $2,500. So, phones are really not a great example, but just taking, say, a loaf of bread, I think our loaf of breads, I remember buying loaf of bread in high school for 69 cents or something. It was pretty inexpensive. And now they're like 250 or something. So it just, that's what your money does not um, buy as much in the future as it does today. And that's just inflation. It's just inflation. So now you can invest the money in the stock market or the bond market, or you can put the money in a bank and earn interest, or you can spend it now instead of waiting. So, because of this principle, long term business decisions are more involved than they initially appear. So, when they're looking at, when a business is looking at a capital investment where they have to get a lot of funds together to, say, build a plant, it's very complicated when you just think, well, they just need to get the money now. No, they need to figure out what is the best way to finance that and if they can even do it. Is it cost effective to even do it? And that's what we'll be looking at in this class. So now, is it worthwhile to invest $10,000 now to get back $100,000 in 5 years? Maybe. Maybe, because it depends on the decision that we're going to be making, right? So, future value versus present value. Um, Future value is how much money invested today will be worth in the future. So, if you had, and Bitcoin is great on this, okay? So, if you had invested $500, I think I was writing, started college, so it's probably 7 years ago. 7 years ago, I was in college. I had just started college, and I thought, wow, I wish I had $500 to invest in Bitcoin. And the Bitcoins were running right about $150 each. And I wanted to invest $500, and I wouldn't do it because $500 was a lot of money. When you're in college, it is a lot of money. So I didn't invest in it. And then just like last year or the beginning of this year, oh my gosh, I could have cashed in, I don't know, like $70,000 or something like that on that investment. Now it's come down, so I could get like about, I don't know, probably about $30,000, which is still isn't too bad. So, yeah. And that's just, if you have $100 today, the value of your investment will be more in the future, provided it goes up. And now, present value is how much future money is worth in today's dollars. So if you will pay me $106 in a year, I'll give you $100 today. So your money is not going to be worth as much, but what is that value in the future today? And a lot of businesses, if you think about it, a lot of businesses are making that type of decision because they want to know how much this investment is today because they're going to buy this investment today or they're going to put this money into an expansion today. And what is it going to be worth, that future money, what is it going to be worth in today's dollars? So future value is usually a saving thing. So if you're saving money, how much money will that be in the future? But present value is typically what a business will want to know when they're making their decisions. So when you're looking at some examples, we want to know if it's future value or present value. Do you want to take that money and know what it's going to be worth later? Or do you know what it's worth later and you want to know what it's worth today? And you have to figure out those decisions because you want to know what tables to use and what your answer should be so that you don't make a mistake. So these examples, and we'll go through these, and of course this is where it was supposed to be really cool and it was supposed to come in with the present value, future value information, but I didn't do that. So looking at these examples, so Joan's grandpa promised her $20,000 when she graduates from college after 4 years. What is the value of that $20,000 today using a discount rate of 12%? That's a present value because we know that at an end of 4 years, that's going to be $20,000. And the discount rate, that's a term that they use because it'll be less. It'll be less today because it'll be worth $20,000 in 4 years. So they call that the discount rate. And you'll see that in the problems that we're going to be doing. And the second one, so that's a present value problem. That's the first thing you need to know to address these problems. The second one is Adam recently purchased a new TV for $5,000 on his credit card. Oh my gosh. First of all, $5,000 for a TV is way too much. But I remember when I worked at Costco, we had $5,000 TVs. And we stocked them. We were afraid to even touch them because we didn't want to hurt them. And $5,000, people bought them. And whoa. I mean, it's crazy. But on his credit card, if his interest rate is 12%, which is pretty normal for an a credit card these days. In fact, I just got a credit card offer in the mail. And depending on your credit, the rate could be anywhere between like 15% and 29%. 29% on a credit card. That's nuts. So 12% is actually pretty good. And this one compounded quarterly. How much would Ryan owe after 5 years? That'll make you think about putting anything on credit. Okay, and that's a future value because we have the amount today. We want to know what it is in the future. So that's future value. And that's a pretty easy way to think about it. So now Joan won the Georgia lottery, which pays $1 million a year for 20 years. If Joan plans to save each of these payments, can you imagine the discipline, the self-discipline she would have? I couldn't do it. I just couldn't do it. I would invest a bunch, but I would still spend some. Until she had received all of her money, how much will she have once the last payment is made, assuming that Joan's bank pays 3% interest? We have the amount today, so we want to know what the future is. But this is different again because the last two examples were just lump sums because It was just one amount. They put one amount in for Joan's grandpa. They're jumping back up to the first example. Joan's grandpa is putting the money in today, and he's going to have $20,000 at the end of 4 years. So those are lump sums. Also, in Adam, with the purchase of the new TV, the $5,000 went on his credit card in one lump sum. So again, that's lump sum. But if you're talking about payments or any kind of payments that are consistent, one a year, those are annuities. And this one is a future value of an annuity. So we'll use a completely different chart for this problem. And then the last one year before retiring, Lindsay was offered the opportunity to buy an annuity that will pay her $35,000 a year for the next 12 years. Now, this is, I didn't really understand annuities, but a lot of people do that. They purchase these annuities for a certain amount of money, and then they're guaranteed $35,000 a year, say in retirement, for 12 years. And so they know what their income will be. When you're in retirement, you look at what you have and you you look and see how much income you will have, how much you will need, and then how much you can have. And so that addresses your spending and what you have. So typically, retirement is a set amount. It's a fixed income depending on how much you have saved for. Then your fixed income is higher or lower. So what is the maximum amount Lindsay should be willing to pay for this offer, assuming that the appropriate discount rate is 10%? Now, this is a present value of an annuity because it's the payments, but she wants to know how much she's going to pay for this today to get $35,000 a year for the next 12 years. So we'll be using the different charts, and I've pulled those up, and they're also online. And what I did is, this is just in a spreadsheet. So we've got future value of a lump sum, and this, I can make that bigger. I can make that bigger. We've got present value of a lump sum. So this is just one. Future value of an annuity. These are the payments, okay? And then present value of annuity. And you want to make sure, first of all, you have to use the right chart, and then you want to use the right future value and present value chart. And so you have to get it clear in your head. Are you looking for the present value? Is it a lump sum or an annuity? Or are you looking for the future value, and is it a lump sum or an annuity? And once you get that straightened out, then you can continue on with your examples. So again, I already jumped the gun here. So we need to know future or present value, okay? And then we need to know the interest rate per period. So that information needs to be somewhere in the problem. The number of periods, is it is it yearly, is it annually, is it semi-annually, is it quarterly, is it monthly? So we need to know that. We need to know the principal. And depending on the principal, if we know the principal today or if we know the principal at the end, that will dictate future value or present value charts that we're going to use. And we need to know the interest payment. So we also need to know the payment will be made, lump sum or annuity. So we already discussed that. So you need all of this information to start working on the problems. So we have certain types of annuities. We have an ordinary annuity. I know this gets pretty complicated pretty fast, but it's not too bad. It's really not too bad. So ordinary annuity is the payments are made at the end of the period, and this is the most common way. So ordinary annuities, just the payments are made at the end of the period. And so trying to think of an example and then I just went blank. So annuity due are payments made at the beginning of the period, typically used for leases. So you would pay the first, it's like rent. You would pay in the first of the month and then the lease would cover that month. That's an annuity due. And then deferred annuities, the payments begin after several periods. So, for example, if you make $10,000 a year for 5 years, beginning 3 years from now, so that will just increase your periods when you make that first payment. Okay. So it gets, I know that does seem a little complicated, but it's not too terribly bad. And you won't use that very much, but it is an option. And the deferred annuities, we don't have that. Well, you have to make the adjustment on the charts. Let's put it that way. So now doing the calculations, there are 3 ways to calculate time value. You can use a financial calculator, and mine is just really simple. In fact, I bought this. It's just the BA2 Plus, Texas Instruments. I've been using that since I first started college, and that's worked out really well for me. Oops. Excuse me, that got that cold, and I still have the cough. And then you can use the exponential functions or use the tables. And you should have a financial calculator at this point in college. If you don't, you should get one and learn how to use it because they're all different. I know I like this one, and some are a little more complicated, and other students like those better. But I just learned on that, and that's the one I've kept using. So can we get started? Oh, yes, and then the tables. And I've showed you the tables, and they're online. You can print those out or download the file of them. And so that's what we're going to use is the tables because everybody has access to them, and then we can all get the same answer. Okay. So let's take a look at these examples, and this will take us through a few. Oops, sorry. That probably heard that, right? When I touch it, I think it makes a big noise. So this is a great way to figure out how to do these, and it's really quite interesting. So the first example is Joan's grandpa promised her $20,000, right, when she graduates from college after 4 years. What is the value of that $20,000 today using the discount rate of 12%? So we have all of our money, I'm going to have to insert a page break. Oh, no. Right there. All right. So we're looking for a present value of a lump sum. And so this will be our formula. We've got future value multiplied by the principal, and that is $20,000. So we're looking for the present value because we have the future value. And whatever you have, future value or present value, you'll be looking for the other one. And that's one great way to look at it. And our interest is 12% from the information. And then our number of periods, our N. I'm just going to use N. Can't be. We're going to have to use periods. And it's 4 years, annual. So our formula will be present value. I know this is a lot easier to write out on my paper, but future value multiplied by, present value N. N multiplied by the percent. Okay. So now we're just going to fill this stuff in. We're looking for the present value, so we don't have that yet. And that shouldn't be that. It should be an equal sign. Okay. Future value. Oh, look, it says you have too many lines. Okay. The future value is $20,000 multiplied by 12%. Okay. Really? It just wants a space in there. It says has to have a space. Present value is 20,000 multiplied, and now we're going to have to go to our tables. And we're looking for 4 periods at 12%. So we need to find present value of a lump sum, and we want to look at 4 periods at 12%. Right there. 4 periods, 12%, and we've got 0.636. 0.636. And you multiply that out, and you're going to get future value of 12,000. I know, crazy, right? 12,710 to about, to about 12,720, depending on your rounding. So, because some calculators go out farther. Anyway, this is what you're going to have. And this is great too. If you want $20,000 in 4 years and the bank's going to pay you 12%, if you put $12,710 in today, in 4 years you'll have $20,000. That's pretty cool, right? Yeah. So the next one, if we go back to our PowerPoint slide, remember Adam, he bought that new TV for $5,000 on his credit card. Okay, so if his interest rate is 20%, which is pretty common, how much will Ryan owe after 5 years? This one almost makes me cry. Okay. So I should label that. I'm going to bump it down. And I'll say, is it Joan? Yeah, it's Joan. Joan. And now Adam. So now this is a future value of of a lump sum, and our formula here, here's our information. Present value, which is our principal, is equal to $5,000. Okay. And our interest rate, I'm going to move that up so we can see it. Our interest rate is, now since this is compounded quarterly, we have to do some work here. Our interest rate is 20%, but we have to divide that by 4 because it's quarterly. So it is 5% quarterly. Because if you have a percentage rate and you compound that quarterly or annually, you have to break that down into that quarterly interest payment. And our N here, just does that. You have to do it twice. Is 5 years, but the interest is compounded quarterly, so our N is 20 periods. Okay. So you have to figure that out. And now our formula is future value equals the present value multiplied by the future value n, n, and the percent, n multiplied by the percent. So now we just fill these in. So future value, so we did the present value on the first one. Future value, the present value is $5,000 multiplied by 20 periods at 5%. So now we need to go back to the chart. Let's do this first though. 5,000 multiplied by we need to do future value of a lump sum, and it is 20 periods, 5%. So future value of a lump sum, 20 periods at 5%. 5%, 20 periods, 2.653. 2.653, and our future value is going to be equal to $13,266. Adam is going to pay $13,266 for a $5,000 TV. Ouch! Ouch! And after 5 years, it might be worth $500 or $1,000. Not a good investment. Not a good investment. So that just shows you how not cool credit cards are. And I mean, I have used credit cards. I have. And I've put big balances on them and I've paid them off slowly. Not the best thing to do. Okay. So I just don't want anybody to feel bad if they have credit card debt, because I know it's a necessary thing and I've done it. Okay. So now the next one is Joan. She won the lottery, remember? And it pays $1 million a year for 20 years. So we want to know how much she has at the end after all of her payments, assuming that Joan's bank pays 3% interest. Now, of course, this doesn't take into taxes, right? But I think I'm going to move down because I'm going to run out of paper. So this is, I forgot her name. Joan again? Wow. That's a pretty lucky lady, right? Joan's lottery. She got money from her grandpa and now she's winning the lottery? Woo! Go Joan. Okay. This is a future value of an annuity, because it's being paid once a year. So our present value of an annuity is the $1 million. And then our interest rate is 3%. We got that. And our N, oh, stop it. I wish I could figure out how to make that. I know there's a way. You guys are telling me there's a way. It's 20 years. Okay. So now we're going to go future value of an annuity is equal to the payments multiplied by the future value of the annuity multiplied by which is the N and the percent. And now that we have our information and our formula, we can go ahead and fill it in. Future value of an annuity, the payment is $1 million multiplied by future value of annuity 23%. So future value of an annuity is equal to $1 million multiplied by future value of the annuity is future value of an annuity 20 periods multiplied by 3% is not the number I'm looking for. What did I do wrong? Present value of an annuity? No. Future value of an annuity. Oh, I was on 18. That's misleading. See where my 20 is there? 20 should be down here. It's on line 22. That's misleading. Okay. 20 periods, 3%, 26.870. So that's what we need to put in there. 26.870. So our future value of this annuity after all of those payments is going to be $26,870,000. And that's not too terrible, but at 3%, she should invest that money because typically you're going to earn more than 3% on an investment. Just saying. So she could have a lot more money than the 26 million at the end of all the payments. Okay. I know. Investments. As long as you make good investments, you should be in good shape. Okay. So the very last one. 1 year before retiring, Lindsay was offered the opportunity to buy an annuity that will pay her $35,000 a year for the next 12 years. What is the maximum amount Lindsay should be willing to pay for this offer, assuming that the appropriate discount rate is 10%? So we want to find the highest price she should pay in order to get this, to make this investment a good deal. So what was her name? Lindsay. Oh, whoa, bold. Lindsay. Okay. Lindsay. I want to spell it right. Okay. Lindsay. Is that an A-Y? E-Y. Okay. So now we have the future value is equal to $35,000. Okay. And the interest rate, 10%. And the ends is 12 years. So let's go over here and figure out how much is she going to get? Multiplied by 12 is $420,000. This is what she's going to get in all the payments. So now we're looking for the present value because we know the future value. Okay, here's the future value. In fact, I wish I could pull that down. I don't think I can. Okay, so here's the future value is $35,000 payments. So the future value is the payments multiplied by the present value of the annuity times the N and the percent. That's your formula. So the present value is equal to $35,000 multiplied by 12 at 10%. Okay. And your present value is equal to 35,000. Whoops, 35,000 multiplied by the factor in the table. We're looking at 12 ends, 10%. And this is the present value of an annuity. And so we need 12 ends and 10%. and we get 6.814. 6.814. So the present value of the annuity is $238,490. Now, should she buy this? Is this a good deal? Well, she's going to get $420,000. So, yeah, that's a pretty good deal. Although not all annuities are, so you need to get with a financial advisor. But yeah, that's a pretty good deal. If the annuity is on sale, if the salesman is trying to sell you this annuity for $300,000, no, it's not a good deal. If the salesman is trying to sell you this annuity for $220,000, buy it. That's a great deal. Okay. So I am going to end this session right here. And when we pick this up, we will start talking about bonds. Okay. So thank you, and we'll see you next time.